Hello class, welcome to this video on the AP Stats Chapter 4 review. So let's go ahead and start on the questions here. We got a lot to cover. So the first question, a local college has a total of 11,000 students planning to attend an upcoming school year, which includes 3,000 incoming freshmen. The athletic director wants to get an estimate of what percent of the incoming freshmen wants to purchase tickets for the football games. She takes a random sample of 400 freshmen and contacts them by email. All right, so it says identify the sample. So here, the sample, remember, is a subset of the population, and the population is everyone. So here you're taking a random sample of the 400 freshmen selected, right? All right, and then you got the population. In this case, remember, they're giving you two pieces of information. They're saying that the local college has 11,000 students planning to attend the upcoming school year, but it says they include 3,000 incoming freshmen. Now this sample is the 400 freshmen, right? So that means that the population is the 3,000 freshmen from which you selected the 400, right? So you got to be careful here. It's not the 11,000 students, it's the 3,000 incoming freshmen here. All right, so number two, it says a city planner is researching a proposal for a new community building project that would require a destruction of protected wetlands. The city planner creates a poll on social media to find out how people in the city feel about the proposal. 93% of the people who responded were against moving forward with the community building project. So what type of sampling method was used? Okay, well, it says that they create a poll on social media and people responded to the poll. So that means that you'd have to respond. That's voluntary, right? So you need volunteers to respond to a poll. Okay, so this is a voluntary response. All right. There was an open invitation. And the participants self-selected. Okay, so voluntary response. Part B, it says explain how the sampling method might lead to bias. Well, the proposal was about the destruction of protected wetlands, right? And so people that feel more strongly or have strong opinions about protecting the environment and things like that are probably more likely to volunteer for this, right? So that's something that we want to keep in mind. So those who have strong views on environment protection are more likely to volunteer in the survey. Than those who don't feel strongly about the issue. Okay, and as a result, do you think 93% is higher or lower than the 2% of people that are against the project, right? So they're going to be, if these people have strong views on environmental protection, there's going to be more people that are going to be against it, right? And so this is likely an overestimate of the true proportion of people, okay? So this is likely higher than the true proportion of people against the project. All right, so that takes care of that. So we have number 3 is another type of sampling method. So it says a group of entrepreneurs is thinking about opening a new business that provides remote workers with a shared workspace and good internet access. As part of the research, they interview people at several local coffee shops. Based on the interviews, they conclude 85% of people in the city are remote workers. All right, so this says here they interview people at several local coffee shops. And notice the keyword local here. They're not randomizing the shops. They're going to local areas. Okay, so that indicates that there's a convenience sample taking place, right? So we got a convenience sample. All right, so they contacted people that were easy to reach. Okay. All right. So part B, explain how the sampling method might lead to bias. Well, if you're thinking about it, you're opening a new business to provide for remote workers, right? And you're interviewing people at coffee shops. Now, who tends to like going to coffee shops? Well, people that like coffee, but also those that just want to get work done, work from home, work away from the workplace, remote workers, people that want to do, projects, things like that are on the computer. So the coffee place is suited for that sort of business. So we would expect that this would be an overestimate of the people in the city that are truly remote workers, right? That are actual remote workers. So we're gonna say that in this case, people at coffee shops are more likely to be remote workers than those not at the coffee shops. And as a result, we're going to claim that it's higher, okay? So the 85% claim is likely higher than the true proportion of people who are remote workers. All right. So number 4, Apple uses a Net Promoter Score to measure customer experience. The NPS measures the likelihood that a customer would recommend the company to someone else. Suppose an Apple Store manager has a list of all 91 customers for one day at the store. She wants to take a random sample of 10 of these customers to estimate the Net Promoter Score for that day. Describe a method for taking a simple random sample using a random number generator. Okay, so we want to take a random sample of 10 of these customers, and all right, and there were 91 customers for one day. All right, so we're going to use those two pieces of information. We're going to select from the 91 and take us 10 customers. Okay. All right, so remember, label, randomize, select, right? Those are the 3 things. So first, label each customer. with a unique number from 1. Now it says we want, random number generator. So we're going to say from 1 to 91. Use a random number generator. To select 10 numbers. 10 different numbers, right? Between 1 and 91. Okay. Contact each customer corresponding to the numbers selected. All right, there you go. Now it says using names in a hat. Okay, so we're gonna put these names in a hat. We're gonna mix the hat very well, right, and so on and so forth. Okay, so so write each customer's. Oops. Name on equal sized pieces of paper. And the pieces of paper have to be identical so that you're not inadvertently picking one that's different than the rest, right? So, all right, and then okay, so put the papers in a hat and mix or shuffle them well. Okay, or mix them well. Randomly select. We're selecting 10 different ones, right? So 10 pieces of paper from hat without replacement, meaning that you're not putting the slips back, right? So without replacing them. Okay, contact each customer listed on pieces of paper selected. All right, takes care of that. And then number 5. So one method of selecting a random sample is using a table of random digits. The table includes a series of random digits, 0 to 9, arranged in rows and columns like this. Suppose the manager at the Apple Store wants to select a random sample of 10 customers from the 91 customers for a day. Describe how to select a simple random sample, or SRS, using the given table of random numbers. Which customers will be selected? All right. So we're going to first describe the process. Okay. So again, labels, randomize, select. So label each customer with a unique 2-digit number from 01 to 91. This is the one where you're using the table of random numbers, so you need the 01 here, okay? So make sure to include the 01. All right, so move left to right in the table of random numbers. Two digits at a time. Ignore numbers 0, 0, and then anything 92 to 99, okay? And repeats, okay? And repeats. Okay, selecting 10 different numbers. I'm just going to put the number 10 here. 10 different numbers. All right, contact each customer corresponding to number selected. All right, so now which customers will be selected? Okay, so, all right, so using that process, we have, okay, so we have 59. Okay, so we got 59, check, right? So that's good, all right, so that's check, because it's between 01 to 91. 23, all right, check. 54, check. 85, check. 06, yeah, that's good. No repeats so far, anything like that. 93, nope. Because it has to be up to 91. 43, right, check. 15, check. 07, okay. 54, no, because that's a repeat. 38, check. And then 86. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There you go. So there's my customers selected. All right, so a local Amazon distribution center delivers products to 3 different states. There are 14,500 purchases delivered from this distribution center on one day. They want to send a customer service survey to a sample of 100 customers who got one of these deliveries. Describe a method for selecting a simple random sample. Okay, so we got 14,500 purchases that we want to look for, that we want to randomize, and we want to select 100 of them. Okay, so label each customer with a unique number from 1 to 14,500. Use random number generator. To select 100 different numbers. Between 1 and 14,500. Okay. Send survey to customer corresponding to number selected. All right. Is it possible that there are no customers from Michigan in the simple random sample of 100 customers? And the answer is yes. We have people from Illinois, Michigan, and Ohio. It's very possible, because it's random, that we would get people only from Illinois and Ohio and not from Michigan. Because it's truly random. So that means it's a possibility. Because remember that when you're doing a simple random sample, every person has an equal chance of being selected. And so it might just so happen that you've chosen people from Illinois and Ohio, but none from Michigan. So that's totally possible, okay? So the answer is yes. the sample is a simple random sample, so there's no guarantee customers from a particular state would be represented. Okay, so now how could Amazon ensure that customers from all three states are represented? Well, then in that case, you'd have to take X amount of people from each state, right? And that is what we call a stratified sample. A stratified, you break them up into the states as a strata, you select from each thing, you do a simple random sample of each of the groups, and then that ensures that you get all three states represented, okay? So that's where we're headed with this. Use stratified random sampling with states as the strata. Select an SRS, a simple random sample from each state. To ensure all states are represented. Okay, there you go. And so easy fix. So, all right, so number 7, a high school principal for a small high school of 400 students wants to survey students about a new proposed requirement that athletes must maintain perfect school attendance in order to continue to participate in sports. She decides to select a stratified random sample of 40 students. Would it be better to stratify by grade level or by whether or not students are athletes? And explain. Okay, well, it doesn't seem like you'd want to stratify by the grade level because this is talking about athletes here, right? It says the requirement is that athletes maintain perfect school attendance. So we're talking about athletes. So it would be more appropriate to do it by whether they're athletes to see like, okay, is there a difference in opinion whether you're an athlete and you're in support of that proposal versus whether you're a non-athlete and you're in support of that proposal? And that seems to be make better sense than to just stratify by grade level, okay? So we're going to say whether or not they're athletes. Okay, opinions about the policy are likely to be affected by whether or not a student is an athlete. As opposed to their grade level. Okay, so describe the process for selecting the stratified random sample. Okay, so we got 400 students here, and we want to take a stratified random sample of 40. So, and we want to split them into two groups, athletes and non-athletes. Okay, so now here they're saying they're not asking to describe a method, like for example using random number generator or anything. They're just asking to describe the process in general. Okay, so keep that in mind. They're not asking for a specific method. Okay, so the process is we split the population into athletes and non-athletes. Select a simple random sample from each group. Combine all selected students to form the stratified random sample. Okay, remember that SRS, guys, means simple random sample, not to be confused with stratified. Okay, we never use SRS for stratified. We use simple SRS for simple random sample. Okay, so just a little note when you see that, that means simple, not stratified. Okay. Okay, just as a side note. All right, so number 8, a large fast food restaurant has a total of 150 employees. There are 220 employees paid hourly and 30 employees on management salary. The owner of the restaurant wants to select a sample of 20 employees to attend a team meeting. So describe a potential issue with selecting a simple random sample of 20 employees. Well, yeah, the simple random sample is fine, but there's no guarantee that all 20 employees will be of a particular salary. So it's possible that all 20 employees are paid hourly, right? In fact, since there's more employees paid hourly than on management salary, it's probably a good chance that you're going to select, probably a chance that you would select a lot of employees that are paid hourly, right? Just because there's more of them represented, and so you can pick, there's more to select from. So even though a simple random sample guarantees everybody has an equal chance of being selected, because there are more of these guys, they're more likely to be selected than, for example, if you look at the other group. Okay, so these are things you want to keep in mind. So it's possible, and it's also possible that you would select all employees to be on management salary, right? There's no guarantee when you're doing things randomly. Okay, so there's no guarantee. So it's possible that all 20 employees selected would be hourly employees or all management. Okay. Suppose the owner decides to take a stratified random sample, select an SRS of 10 hourly wage employees and an SRS of 10 management and salary employees. Are the employees within each group homogeneous or heterogeneous? Okay. So because you're taking, you're breaking them down by the type of employee, that's going to be a homogeneous, right? So because they're all the same type of people, whether they're all salary or whether they're all hourly wage, right? So all employees within each group are similar in their paid status, or in how they're being paid, how they are paid. Okay, so the owner realizes that using equal sized groups for the hourly wage employees and management salary employees is not representative of all employees. Well, that makes sense because you have way more employees paid hourly than those that are in management. So what sample sizes should be used for each group in order for the stratified random sample to be representative? So this is something that we didn't talk too much about, but it's important that you want to represent each well, right? To be representative of all employees. And so what we want to do here is, well, if there's 150 employees and there's 120 and 30, and we want to select 20 employees, right? Well, let's do the math here. We have 120 that are paid out of 150. Okay, so if I divide that by, if I just reduce that fraction by 30, that's 4/5. Okay, so that's 4/5 of the population. Okay, so that's 4/5 of what? So 4/5 of my, and I want to select how many people? 20 employees, right? So 4/5 of 20 is going to be 80 divided by 50. So that's going to be 16. Okay, so we did that on the calculator. So this is, this represents 16. So this represents 16 paid workers, or hourly, I'm sorry. They were all paid, but hourly, paid hourly. And then that means 1/5 are salary. So 1/5 of 20. So that's going to be 4 salary. And if you select them in this manner, then it's going to be more representative of the population of the what you have, right? Okay, so it would be 16 hourly wage employees and 4 management salary. All right, employees. All right. Okay, so the next one. This is for number 9. At a certain high school, every student is required to take an English class each year. English 9 for freshmen, 10 for sophomores, so on and so forth. They're also required to take physical education each year with multiple grade levels. Okay. The high school counselor wants to use a cluster sample to estimate the proportion of students who have their driver's licenses. All right. So should the counselor use English classes or the physical education classes as the clusters explained? Okay, so now it's important to realize that for the English class, the groups are homogeneous. So English 9 is just freshmen, English 10 is just sophomores, just juniors, English 12 is just seniors. So each class has only the homogeneous grouping, so the same type of people. Whereas physical education has multiple grade levels in each class. So you're able to get different groups of people, right? So you're able to get more representation, variety within that. Okay, so in that case, because if we want more representation, we want them to be heterogeneous, right? Then we want to use clusters based on physical education. So the counselor should use the PE classes as clusters due to multiple grade levels represented in each class. Which would allow for heterogeneous clusters. Okay. All right, so what is one advantage of using a cluster sample compared to a simple random sample? Well, the advantage is that the data is easier to collect. Okay, so data is easier and more efficient to collect. Now, in this case, what we can, the counselor would just have to go to a few rooms, right? To only a few rooms to interview all students in those rooms. rather than going to many rooms, because you're selecting students with a simple random sample rather than selecting a few students in many rooms. Okay. All right. So each Major League Baseball team, MLB, is allowed to have 26 players on their roster for opening day. With 30 MLB teams, this means there are 780 players on the opening day rosters. An avid baseball fan wants to select a simple random sample of these players. Describe a method for selecting a simple random sample of 100 players. So we want 100 players, and we have 780 players on the opening day rosters, and we want to select 100 of them. Okay. So remember, label. So label each player with a unique number from we're gonna use a simple it's a random number generator. So then we'll just say from now we have 26 players on the roster. Okay, so we won't need that for this part. Not for this part. From 1 to 780. Use a random number generator to select 20 or 100 numbers. We're doing 100 players. 100 number or 100 different numbers, right? I guess I should put that. Sorry about that. If you want, you can put 100 numbers, no repeats. Same thing. Between 1 and 780. Select each player corresponding to numbers selected. Okay. All right. Describe a method that could be used to select a stratified random sample of 90 players. Okay, so we want 90 players. We want a stratified sample. Okay, and then also it mentions there's 30 teams. Okay, so what are we going to split them up into? We're going to use the teams as strata, right? So let me just put in here teams equals the strata. Okay, so we have 30 teams, 30 strata, and 90 players. So 90 divided by 30 teams, 3 players per strata, per team that we're going to select, right? Okay, so that's how we're going to set it up. So, and so there's 30 teams. So let me put 30 teams. So that's your 30 strata. Okay, so we have the 30 teams as our strata. We have 3 players per team. But now we have, if you go here, we have 26 players, right, on the roster. Each team is allowed to have 26 players. So when we select the 3 players per team, we have to choose them from 26 players, right? So for a particular team, what we're going to do is, because there's 26 players on each team, if I go to one team, I'm going to label those players from 1 to 26, and then I'm going to choose 3 players from that team, and I'm going to do this for all 30 teams, and that's how I'm going to get 90 people, okay? So I'm going to put 26 players on each team. Okay, so when we set this up, we're going to set it up for one team and then just repeat this for all 30, okay? So for one team, we want to label each player with a unique number. From 1 to 26, we're going to use a random number generator. To select 3 numbers. We want 3 from each team, right? So, oops, excuse me. Usually I put a number there, but I'll just write it out. So 3 numbers. Well, 3 different numbers. I always forget to put the different numbers. 3 different numbers between 1 and 26. And then select each player corresponding to numbers selected. Repeat this process. Repeat process for all 30 teams. All right, so there you go. So that's how you do it. Now, so for the next one, describe a method that could be used to select a cluster sample of 78 players. Okay, so we know that there's 30 teams, or yeah, is it 30 teams? Yeah. Hold on, let me double check. Yeah, 30 teams. So 30. We know we have 30 teams, and we have. All right, so remember that the stratified sample we selected from each team, right? A certain amount of people. Here we're doing a cluster sample, which means that we're only selecting some of the teams. Okay, so that means we can't select from each team. We can only select some of the teams. And if we select some of the teams, then we can just select players from each team, right? Or from those teams. Now there's 26 players per team, and we want 78. Well, okay, so then how many teams are we going to need to select here if there's 26 players on each team? Well, 78 divided by 26 is 3. So we need to select 3 teams. Once we select 3 random teams, then we can select all 26 players on each team, okay? So that's the idea. So label each team with a unique number from 1 to, there's 30 teams, so from 1 to 30. Use a random number generator. To generate or select, we want 3 teams, okay? So select 3 different numbers between 1 and 30. Okay, that'll help us pick out the 3 teams. And then for each team, we're going to select every player for each team corresponding to number selected. So for example, if I get number 2 as one of the teams, then I'm going to select team number 2, all 26 players in that team, okay? And then keep going. All right, so now describe a method that can be used to select a systematic random sample of 78 players. All right, so how many people do we have? Well, it says we have 780 players, right? So we're going to select each player is going to get a number, all right? And how do we know how many, like every third, every fifth player, like how do we figure that out? Well, we have 780 players and we want 78 of them. And so 780 divided by 78 is 10. So we're going to select every 10th player. Okay, so we need a random number generator to pick the first number. And then from that, we can select every 10th player until we have 78 players. Okay. All right, so label each player with a unique number from 1 to 780. Use a random number generator to select one number between 1 and 30, or 1 and 10, I'm sorry, between 1 and 10, because we want the 10th player, or every 10th player, so then we're going to select one number. Now, this is one way to do it. Another way that you could do it is you can just say use a random number generator to select one number between 1 and 780, right? So you can do that. So you can certainly do that. You can select between 1 and 780, and then that will tell you your first person that you would select. And then after you get that first person, you can just do every 10th player after that. And then that's fine, because if you get to the end of the list, you can just go back up to the beginning of the list and continue. So you can also do that too. That's another option, by the way. Okay. But here, by ensuring that we only choose one number between 1 and 10, this ensures that I don't have to go backwards in the list. I could just continue in the list and get every single person. Okay. So it's up to you how you want to do that. This is just one option. Okay. So one of two options. The player corresponding to this number is the first player selected. Then select every 10th player. Past this player from the list until all 78 players are selected. All right, there you go. All right, so now let's do question number 11. So this was a good question, so you really understand the difference between the methods and then to be able to describe them. Really good question for that. That's why I wanted to give you that type of question. All right, so number 11, Zillow wants to estimate the average value for houses in Chicago, which has 178 official neighborhoods. To do this, they'll select a random sample of houses in the city and send an inspector to each house to find its value. Option 1, select a random sample of 5 homes from each of the neighborhoods. Option 2, select a random sample of 5 neighborhoods and visit every house in the selected neighborhoods. Okay, so name the sampling method using option 1. So you're just using 5 homes from each of the neighborhoods. Okay, so from each of the neighborhoods. So the neighborhoods are your groups, and you're selecting from every single neighborhood, but only 5 homes from each neighborhood. That's stratified. Okay, and give one advantage of using the sampling method. Okay, so we got stratified, random sample, and then on the other hand, name the sampling method. So it's option 2, select a random sample of 5 neighborhoods. So you're using clusters. You're getting those groups, 5 groups, and every house in each group. Okay, so that's a cluster. Okay, so cluster sample. Okay, so the benefit of the stratified is that it guarantees that you get houses from every single neighborhood, that every single neighborhood is represented. You might have, for example, some wealthy neighborhoods. You might have, for example, some not so wealthy neighborhoods, right? So you get each neighborhood represented, right? Now, the thing about the cluster sampling is that it makes it easier and faster to collect the home values, because you can just do some of the neighborhoods and you don't have to visit every single neighborhood, right? So it's efficient in that sense. Okay. And then we'll talk about which one's going to be the better method, as far as estimating. All right, so here, this guarantees houses from every neighborhood are represented. Okay, and then part B, we said that it's makes it easier and faster to collect data on home values, since inspector only needs to go to 5 neighborhoods. All right. Okay, so now, which one is going to be more likely to produce better estimates for the true average house value in Chicago? Well, as we mentioned earlier, option A, or option 1, allows for every neighborhood to be represented. Option 2 doesn't allow that, right? Because you might have only 5 neighborhoods, but then those neighborhoods might be, for example, well-off neighborhoods. And so if you were to do that, you're not really representing every neighborhood, and so your values are going to be different, right, than what it would have been. Okay, so here, because of better representation in option 1, that's going to produce the better result. Okay, so we have the stratified random sample. Because neighborhoods may vary by houses, by pricing of houses, by value of houses. More expensive neighborhoods, etc. Okay, so you might have neighborhoods that have more expensive houses. That's what I mean. But this ensures that houses from all neighborhoods will be represented. Okay. All right, so number 12, the Gallup organization conducts surveys to find out public opinion on a variety of current topics. They often use complex methods to select their samples. Suppose they're considering 4 different sampling methods for estimating the president's job approval rating. For each of the following sampling methods, create a dot plot which represents the estimates from 10 simulated samples. Suppose that the actual job approval rating of the president is 45%. Okay. So we have to create a dot plot that has each of these scenarios. Low bias, low variability. Remember that low bias and low variability. Remember, bias is when you're off target. Okay, so this is the target. If you're consistently off target, we call that bias, right? And right now, this is bias with low variability, because these shots are not very spread out. If you have bias with high variability, then it's going to be off target, but they're going to be kind of spread out, right? That's bias with high variability. That's high bias, high variability. Then you have low bias and low variability. So that means that the targets are are on target on average and they're not spread out. Then you have low bias, high variability with on average, you're on target, but the shots are kind of spread out. Okay? So those are the 4 different scenarios, and we have to draw a dot plot that represents that. Now keep in mind we have 10 dots that we're going to use, okay? All right. So let's do dot plots for these, right? Oops, sorry about that. All right, and we'll go from, let's say we go from, I don't know, 26, and we'll go all the way to 20. We'll go by twos. And something like that, okay? I'm going to try to move this a little bit to the left so that I have more room. Sorry about that. There you go. All right, so we'll do this. Let's just do this for all of them. I might as well. Okay, so we can copy and paste these. All right, so we got here. All right. Okay, so now if we want low bias, low variability, we want the approval rating to be 45% on average, according to this. Okay, so let's do 10 dots where they're not very spread out, but the average or the median is 45%. Okay, that's what we want to do. So that means in the middle it's going to be about 45. So let's do, like, for example, let's do like 1, 2, 3 dots right there at the 45. We'll do 1, 2, 3, 4. Yeah, let's do 2 dots here and here. Okay, so they're very low spread. So 1, 2, 3, 4, 5, 6, 7 dots. And then maybe we'll do 8 dots here. So that's 8 dots total. And then we can do like 1 here, 1 here. So that's a total of 10 dots. Okay, so low variability, low spread. It's not very spread out, right? And it's low bias. So notice that the average, the median here is 45, right? But it's not very spread out. Now let's do one where it's low bias, high variability, right? So on the other hand, so it's gonna on average be about 45%, or on yeah, we could say on average or around there. And it's going to be high variability, so high spread. So let's do, okay, so let's do that. So we'll do maybe couple dots at 45, and then we'll kind of spread it out from there. So let's do maybe 1 here, 1 here, 1 here, 1 there, 1, 2, 3, 4, 5, 6. So that's 6 dots. Okay, sorry about that. Let's do 1 dot here, a dot there. So 1, 2, 3, 4, 5, 6, 7, 8. And then, yeah, and then we can do another here, 9, 10. Okay, so it's kind of spread out, but notice that it's symmetric, right? So that way we know that we know that the middle is 45%, but it's spread out. Okay, so that's high variability, high spread. Okay, so hopefully that makes sense. All right, so now we got a sampling method with high bias and low variability. Okay, so high bias and low variability. So what we're going to do is high bias, meaning we're off target. So let's do this off to the left side, shall we? let's go around 36. Okay, so let's make one like this, right? But let's do it around the 36. So 1, 2, 3, 4 maybe. And then we'll do here 1, 2, 1, 2, maybe 3 here. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's 10. So it's low variability, right? It's low spread. It's not very spread out. And the average here is 36%, the median. And that's high bias because the true value is right here. That's the true value, right? And so we got high bias. You see that? Okay, so that's high bias and low variability. So we're off target. We're consistently, in this case, for example, underestimating. Now high bias and high variability. So we're just going to do this one where it's like, off target, but it's also spread out. Okay, so we'll do, for example, around 36%. We'll do 1, 2, and then we'll just kind of spread them out. Okay, so we'll do 1, 2, 1, 2, 3, 4. Okay, and then 5, 6, 7, 8, 9, 10. Okay, so it's symmetric. You can see that, and since it's symmetric, that means it has the middle has to be the value, right? The median value, the average value. So that's 36%, and then you know that that's obviously high bias because it's off the 45%. That's the true value, right? So it's off of that, and it's also spread. Okay. All right, hopefully that makes sense. So you can kind of use those concepts. So now we're going to look at the next question. It says Whole Foods is a supermarket known for having natural and organic food, often at higher prices than other supermarkets. They recently surveyed a random sample of their customers. Based on their survey results, they claim 70% of millennials are willing to pay more for high quality foods. And the type of bias that was present in the survey. All right, so because they only surveyed people at Whole Foods, that means they're leaving out people that don't shop at Whole Foods. So that's undercoverage bias when you're leaving out people, right? So this is undercoverage bias. When you leave out people, right? That's what we call that, undercoverage bias. So you're leaving out millennials who don't shop at Whole Foods. Okay, so do you think the 70% claim is true? No, there's going to be bias, right? So here, millennials that shop at Whole Foods are more likely to pay for more high quality foods. So this is actually probably higher than the true amount, right? The true amount might be less than that. Okay, so because we only select the people from Whole Foods. Okay, so millennials who shop on Whole Foods more likely to pay more for high quality foods than those who don't. Therefore, 70% is likely higher than the true percent for all millennials. All right, so there you go. So that's 13. Now 14, Gallup is an organization that collects and shares information about public opinions. Kentwood Public Schools partnered with Gallup to create a survey for teachers in the district. The survey went out to email to a random sample of 100 teachers. 56 teachers responded. One of the questions, okay, so here they did by email, and then you have 56 teachers responded. Okay, so we want to keep that in mind out of 100. One of the questions was, how much time do you have planning each day? Have for planning each day. For the 56 teachers that responded, the average amount was 85 minutes. Okay, and it says, how much time do you have for planning? That's going to be relevant because if you the teachers that are going to respond, they're going to probably say that they have, in that case, they're gonna probably say that they have more time for planning, right? Because they have plenty of time for planning. Well, because I mean they had time to plan, and then therefore, and now they have time to send an email, right? So it's possible that the teachers that didn't respond would have responded that they have less, that they don't have much time for planning because they're busy, trying to plan and they're busy in general. So they'll probably say that they have less time for planning than those who responded. So you can see that there's a bias there. And so here we have the type of bias that we have. It says, does it describe voluntary response, sample, non-response, or both? So this is a non-response bias because we have only 56 teachers responded, so we have 44 that did not respond. So that's a non-response bias, okay? So non-response bias, 44 teachers did not respond. It was an intentional sample of 100 teachers, not an open invitation to all teachers. Okay, so like if it was an open invitation to all teachers and we didn't have an intentional sample of 100 teachers, like we wanted 100 teachers, then it would have been voluntary response, right? But here we wanted 100 teachers and only 56 responded, so we can't really do anything about that. Okay, so we got a non-response bias here. And here it says, do you think the average amount of time for planning for the teachers in the sample is greater than or less than the true average? Like we said, it's going to likely be greater than. Teachers that didn't respond were likely too busy and would have said they had less time planning than those who responded. Okay. One of the administrators suggested a larger sample size. Will this reduce the bias? No. Remember, sample size, a larger sample size will reduce the variability. So here, even if you have bias, right? This is high bias, part C. There's a bias there. If I increase the sample size, it's not going to change the bias. The bias is still there, right? However, what that's going to do is just going to decrease the spread. So it might go from, for example, D, which is a high bias, high variability, and if I have more people, more teachers, then it might shrink it to like this, but the bias is still there. Okay, so the sample size will only decrease the variability if you increase the sample size. Okay, so if you have a larger sample size, it will not decrease the bias. Okay, so no, as increasing the sample size would only reduce the variability. Because the teachers that don't respond are different. than those who did respond. Even if you have more teachers, you're still going to have that bias there, where those teachers that don't respond have the same kind of quality, more like in all probability, than those who did respond. All right, so 15. A new ride-sharing company called Uber Lyft wants to survey their customers with a ride-share experience. Using the app, they send the following request. Our users have consistently had very positive experiences with Uber Lyft. Okay, so there's something right there. They're kind of leading the customer there. We will always continue to strive for perfect 5-star reviews. What is your rating for your experience? Okay, so we can see there's bias with the question wording. Okay, so we have a question wording bias right there. Contains additional info that is leading. Okay, so that means it's leading the customers to make a certain conclusion. We also have response bias. In the sense that because of it says we always continue to strive for perfect 5 stars review, and it says they consistently had very positive experiences. So then if you didn't have positive experiences, if you didn't have a positive experience, and it says here that our users have consistently positive experiences, that's going to make you feel like you need to rate higher than the actual truth. Maybe you did have a higher experience, okay? So users might lie and rate higher experience than the truth. Okay. Due to info in the survey. Okay, so you go, 2 potential sources of bias. All right, so number 16, a middle school band teacher assigns students to practice their instruments at home for 15 minutes per day. They're required to keep a practice log where they record the number of minutes they practice each day. The teacher selects a random sample of 10 practice logs, finds the average amount of practice per day is 17.8 minutes. Name one potential source of bias present in the survey. Okay. Remember that here it says the students, they assign students to practice their instruments. They're required to keep a practice log where they record the number of minutes they practice. So the students have to report their own practice time. What do you think they're going to do? If they didn't really practice, they're probably going to overestimate the actual practice that they had, right? So especially if it's for a grade or something like that, right? So we have a response bias that they potentially might lie or fudge the results, right? So we got response bias. Students reporting their own practice times may not be entirely truthful. Okay, so we have to keep that in mind. So do you think the average amount of time practicing per day reported by the students in the sample is greater than or less than the true average time? Well, we said that they're going to probably overestimate. So we're thinking that it's going to be greater than, right? Students may over-report their practice times for a better grade. Okay. Identify a solution that the teacher could implement to remove this bias. So So we could, I don't know, we could have teacher monitor their practice. So, for example, we can have the students do a video or an audio of their practice, so that, or something like that, so that they have to submit proof, right? Proof of their practice. For example, audio or video recordings. That's something like that. Okay, so number 17. Researchers recruited a sample of pregnant women from prenatal care practices in Connecticut for a study about chocolate intake during pregnancy. Women were interviewed during their first and third trimesters about risk factors for preeclampsia, um, an adverse pregnancy outcome, and their chocolate consumption. Women who reported regular chocolate consumption of 1 to 3 servings per week had a 50% reduced risk of preeclampsia. Is the scenario described an observational study or an experiment, and explain? I remember, observational study, you're not imposing treatment, you're just watching, like observing, collecting data. You're not really imposing any treatments, putting them into random groups, right? Random assignment. Experiment does have random assignment in it. You're randomly assigning them to treatments. Now it says they were just interviewed during the first and third trimesters about risk factors and their chocolate consumptions. So they didn't really. It says women who reported regular chocolate consumption of 1 to 3 servings per week had a 50% reduced risk. So they basically just observed them and asked them. So this is an observational study. Treatments were not imposed on the women. They simply asked them about their chocolate consumption. Okay, identify the explanatory variable. Ideally, we're trying to see if the amount of chocolate would influence the preeclampsia status, right? So the explanatory variable is the amount of chocolate consumed, right? So the chocolate consumption. During pregnancy. And then the response variable is whether or not they developed, right? So whether or not they developed preeclampsia. All right, can the researchers conclude that consuming chocolate during pregnancy will cause a reduced risk of preeclampsia? Explain. Okay, it says cause. Because it's an observational study and we didn't do random assignments to treatments or anything like that, we can't really do cause and effect. Okay, we can only say that there's a relationship between chocolate consumption and developing preeclampsia or not, but we can't say whether it's a cause and effect because we only did an observational study. Okay, so here said no, because it's possible there are other variables that would lead to the same response. So you can't determine cause and effect from observational studies. From observational study. All right. Okay, so does a Mediterranean diet during pregnancy improve child neural development at age 2 years? Study was conducted involving 1,221 pregnant women. The women were randomly assigned into 3 groups for 4 weeks during pregnancies: Mediterranean diet, stress reduction, and usual prenatal care with no interventions. Total of 626 children were assessed, and it was determined that the children in the Mediterranean diet group had higher scores in the cognitive domain and socio-emotional domain than in the usual care group. All right, so is this a observational study or an experiment? Well, now we have random assignment, guys, right? So because it's randomly assigned, this is an experiment, okay? So we have an experiment here. Since women were randomly assigned into one of 3 treatments. Okay, so treatments were imposed. All right. So based on the results, can the researchers conclude that eating a Mediterranean diet during pregnancy caused the higher scores? Well, if it's a well-designed experiment, they have random assignment, then we can certainly make that conclusion, right? Assuming that they well-designed the experiment and all that stuff, right? And they did random assignment, so we know. So based on that, we can assume yes, because it's an experiment here. Okay, so yes, we can conclude cause and effect due to well-designed experiment that includes random assignment. About half of the mothers who initially participated in the study did not bring their children in for assessment. Explain how this could affect the analysis of the results. Okay, all right. So here we're looking at the children of the moms, and it says that the children in the Mediterranean diet group had higher scores in the cognitive domain. So it says did not bring their child in for an assessment. Okay, so then if they didn't bring their child in for an assessment, then what's the reason for that? Were those mothers that didn't bring their children in for the assessment, do they have a particular characteristic? There's about half of them, so that's significant. So it's possible that there's a difference between the mothers who did bring their child in versus the mothers who did not bring their child. So then it's hard to know how the assessment scores would have changed, based on that. Okay, so it's possible that mothers who brought child in for assessment differ from mothers who didn't. Which could impact the results of the study. All right. So, all right. So number 19, does the wording of a request impact children's willingness to help? Researchers wondered if referring to a child as a helper or asking a child to help would affect their behavior. Participants were 51 4- and 5-year-old children who were randomly assigned to one of 3 groups. 17 children who were assigned to the verb condition by asking them to help pick up toys. 17 children were assigned to the noun condition by asking them to be helpers when picking up toys. And the remaining 17 children were assigned to a baseline group without using help or helper. Researchers then measured the number of toys children picked up after being given the directions. They were assigned the noun condition. Those who were assigned the noun condition that they were a helper helped significantly more than the children in the other 2 groups. All right, so we want to draw an outline of the experiment. Okay, so just do an outline. So we have, let's see here, we have 51 4 and 5-year-old children. Those are my EUs, my experimental units. We have 17 in each of the groups, so 3 groups, right? So randomly assigned. Okay, all right, so we got 51 4 to 5-year-olds. And then we have random assignment. All right, group 1, we have 17 4 to 5-year-olds. Another 17 4 to 5-year-olds. And group 3, same deal. All right, and then group 1 was the noun condition, or the verb condition. So asked to help. Asked to be a helper. Okay. All right, sorry about that. Asked without help or helper. All right, and then we're just going to compare the results, right? Compare number of toys picked up. All right, there you go. So that's the outline, the general outline. Identify the EUs. That's easy once we already did all that stuff in the outline, right? So 51 4 to 5-year-olds. Identify the treatments. The treatments, we have the verb condition, help. We have the noun condition, helper, and baseline condition, neither. Okay, and the response variable, number of toys picked up. All right, there you go. That's the study. So number 20, a statistics teacher wants to conduct a study with her students to determine if completing a review sheet is an effective way to prepare for a test. She has 180 students and would like to randomly assign half of them to complete a review sheet made by the teacher and the other half to study on their own. What is the purpose of randomly assigning students to either receive a review sheet to complete or to study on their own? Okay, so basically it's what's the purpose of random assignment? Okay, so the purpose of random assignment is we want to balance the effects of the confounding variables, right? We want to balance the effects of them. For example, some students might be motivated, right? So there might be differences in student motivation, things like that. And so we can say that those differences will kind of balance out or level out as a result of, because we're randomly assigning them to whatever groups, right? And so that the differences that we can see can be contributed to, maybe it might be contributed to the treatment rather than like at those other effects. Okay. Right. So that's basically the purpose. Okay. So to balance the effects of confounding variables, i.e., this is an example. Student motivation. Maybe student motivation differs between those who are trying to prepare for a test, right? And because of that, you want to balance that out. So you want to pick the students randomly, assign them to random groups. Okay. So balance the effects. So that the differences in the response can be linked to the treatment. Allowing for possibility of cause and effect. Okay, so describe a process that would randomly assign 180 students to the two treatment groups. So we have 180 students, so we're going to assign them a number from 1 to 180, and then you're going to use a random number generator, all that stuff. And we have two groups, right? We have a review sheet made by the teacher, and then the other half is study on their own. Okay, so assign each student, or label each student, whatever you want to do, a unique number from 1 to 180. Using number random number generator to select or generate. And now we want to do two groups. So let's just do, we're going to select 90 students for a group. Okay, so 90 different numbers between 1 and 180. Give students corresponding to these numbers, to these selected numbers, a review sheet to complete before test. The remaining 90 students will prepare on their own. Okay, all right, so there you go. All right, so 21, the Food and Drug Administration, or FDA, recently authorized a medication called omalizumab to treat milk, egg, and nut allergies. The authorization came after a study done by clinicaltrials.gov, where the primary objective was to compare the ability to consume foods without dose-limiting symptoms during a double-blind placebo-controlled food challenge after treatment with either omalizumab or placebo for omalizumab. Both the omalizumab and the placebo were administered with an injection. Explain what is meant by double-blind placebo-controlled in the context of the study. Okay, so you just have to explain double-blind. So this means that the patient, here the I guess we should say neither the patients, right? So like the patients are blind and then the researchers are blind, right? So let me change that. Okay, so neither the patients nor the researchers were aware of which treatment was received by each patient. Okay, now, so that's double blind. So this is double blind. All right, placebo-controlled means, okay, so for it to be placebo-controlled, we would have to have patients that have an inactive treatment, okay? Means patients receive an inactive treatment. No actual medicine. As a baseline, to compare to those with the drug. Okay, sorry about that. There's a lot going on there. What is the importance of blinding? So what we want to do, the reason why we need a blind, so blinding is important so that patients don't change their behavior or habits by knowing the treatment. By knowing the treatment they received. So blinding is important so patients don't change their behavior or habits by knowing the treatment that they received. Also, so if we want to blind the researchers, it allows them to unintentionally interpret the results differently. It allows researchers to not unintentionally interpret or analyze results differently. Okay. All right, so what's the importance of using a placebo? So this is the baseline, so that so the placebo is important. So the placebo helps us to do the blinding, right? So the placebo is used to keep patients blind to which treatment they receive. Okay. All right. So number 22, a recent study was conducted to investigate the placebo effect. In the study, 80 participants who were diagnosed with irritable bowel syndrome or IBS were randomly assigned to one of two groups. In group 1, the 40 participants were given a placebo in the form of a sugar pill to treat their IBS. They were told they were receiving a placebo that had shown improvement in IBS through mind-body self-healing processes. The remaining 40 participants received no treatment pill but were given the same quality of interaction with the medical providers. The results showed significant improvement in symptoms for the group who received the placebo compared to those that received no placebo. Interesting. So we have a placebo group and then a group that didn't actually receive the placebo. And so you can actually see the difference between placebo versus no placebo. And so this is giving you an idea of the placebo effect, right? Because you can see a difference between the two groups. So important to identify that there is a placebo effect, right? That's present. Okay, so what's the purpose of including a group with no placebo? So like we said, that's going to be the control group to compare against the placebo, right? So this serves as a baseline to compare the effects of treatment, which is the placebo, on the response. In this case is IBS improvement. Okay. So explain how this study shows a placebo effect in action. Participants, we know that the participants here responded to the pill, right? To the placebo here. So it says participants had a response to the sugar pill, even though it contained no active ingredient. Okay, so this is a good kind of experiment to test the placebo effect. All right, so 23, the governor of Alaska recently proposed a plan to give teachers bonuses to try to increase retention rates.